Hello. So today we're working on pages 45 and 46. The top of page 45 looks like this, representations of a linear pattern. So for number one, it says you studied this pattern in the previous lesson. Use your work from the previous lesson. We're just doing it from here. So we have stage one here, and stage two is all of stage one, but we're adding on a block to kind of each end there. And that's what we do every single stage. Okay? So we're adding one to the top, we're adding one to the side. So how many new blocks are added to this pattern? So every new stage, we are adding 2 blocks to it. So now we're going to complete the table. So in stage 1, we had a total of 1, 2, 3 blocks. In stage 2, we had 1, 2, 3, 4, 5. In stage 3, we had 1, 2, 3, 4, 5, 6, 7. And now we have to talk about, all right, as this is going up 1, so from 1 to 2, we're adding 1. What is our other side going up? So this is going from 3 to 5, so this is going to be plus 2. So we can use that to figure out what the rest of our table should be. We can find this pattern. So if this goes from 3 to 4, it's going up 1, so this side should go up 2. This side from 4 to 5 is going up 1, so the right side should go up 2 to 11. So our rate of change is 2, because as this goes up 1, as our x goes up 1, our y is going up 2. So our rate of change would be 2. So now we're going to take our data from this table and we are going to create a graph. So what I'm going to do is I'm going to start here, 0, and we'll do every line is worth 1, but I'm only going to do every other one, label every other one just to save some time. And we'll do the same thing for this way as well. Everyone is 2, or everyone is 1, but we're only going to label every other so we can save some time. Okay. So now we start with our points. We have 1, 3. So 1, 3 is there. Then we have 2, 5, just right there. 3, 7. 4, 9. And 5, 11. So we'll go ahead, draw our line. Line up all these points. And we'll draw our line. So create a graph of this data. Where do you see the rate of change? So where are we seeing this 2, this plus 2? So if we think about it, every time we go up a stage, the number of blocks we have is going up 2. So for instance, if I went from this point, if the number of stages, so my stages are down here, went up 1, the number of blocks is going to go up 2. So this right here is our plus 2. That's our rate of change. So from one of our points to the next, as this goes up 1, our y value goes up 2. Okay. So then letter E, what is the simplified form of the equation that gives the number of blocks T for any stage S? Alright, so what we have to do is our total number of blocks, we're going to basically put this in y equals mx plus b form. But instead of y, we're going to do the total number of blocks. So we're going to call that number of blocks is t. And then m is our unit rate, which we'll talk about in a second. Then x is our stage. And then b is our like starting point. So the total number of blocks is equal to, and then what we're going to do is we're going to put our rate of change in for M. And every time our stage went up 1, our blocks went up 2. So our rate of change is 2, so we're going to call that 2s. And then this one right here is like basically what we started with. Okay, so we have 2s plus, and we started with, let's see, well, it's going to be plus 1. So if we think back, we like before stage 1, we would have just had 1 block, and then they would have added, or we would have added these 2 on. So we just have that block. So we're adding 2 every time. We started with 1. So that would be our equation there. We can also see in our graph right here that when we started with 1. At 0, we had 1. Okay? So there's a couple different ways that you can find that. And then where do you see the different pieces of the equation in the geometric model, table, and graph? So we're seeing the 2 as the rate of change in our graph, in our table, and then we're adding 2 every single time. And then we see this 1 right here where we're starting. We don't have that in the table, but, and I kind of showed you up here that, you know, if before stage 1, before we added those 2 on there, we just simply had 1 to start. And then letter F, the pattern is a linear pattern. Describe how a linear pattern grows. Okay, so basically what linear means is it just creates a straight line. So it's going up by the same amount every single time. So if we move over 1, it should go up 2. If we move over 1, it should go up 2. And in our graph, it does that. In our table, if this side goes up 1, this should go up 2 every single time to create that linear situation. So we're going to say something like it has a constant rate of change. The graph of a linear pattern just looks like a straight line. So the graph is a straight line. Linear means a line. Okay? All right, so now we're going to jump to the back for number 2. So number 2, the question is very similar to number 1. So we have stage 1 here, where we just start with a block. In stage 2, we're adding a block to these 3 sides of it. So we're going to do that every stage. We're going to add those 3 blocks to every side. So letter A is asking how many new blocks are added to the pattern each stage. So every time we make a new stage, how many blocks are we adding? We're just adding 1, 2, and 3. So now we can complete this table. So in stage 1, we had 1 block. In stage 2, we have 1, 2, 3, 4. In stage 3, we've got 1, 2, 3, 4, 5, 6, 7. Stage 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can use our pattern here because when we're going up 1 on this side, we're going up 3 on this side. So we can use that to figure out this last data point here. So 4 to 5 is up 1, so this side should go up 3, so I'm going to end up with 13 on this side. Alright, so now we're going to graph that information. We're going to use the same kind of scale we did on the one before. Every line is 1, but I'm just going to label every other. Same thing here. Okay. And now I'm going to plot these points. So I've got 1, 1. I have 2, 4. 2, 4. It's right there. And then I've got 3, 7. 4, 10. And 5, 13. Alright, so we've got our points there. And then it says, where do you see the rate of change on your graph? Again, choose 2 points. So I'm going to choose 2 points that are close to each other. Every time this goes up 1, this goes up 3. So this goes over 1, this goes up 1, 2, 3. So our rate of change, or our plus 3, is right in there. Every time the number of stages goes up 1, the number of blocks is going up 3. Alright, so now let's write an equation that gives the number of blocks t for any stage. Okay, so the number of blocks is t. So the number of blocks is equal to the stage. Let's see. So our rate of change is 3. So it's going to equal 3 times the stage. And then we're going to do minus 2. So 3 times the stage minus 2. So if we look at that, we can see in our table, if we do 3 times 2, that gets us 6. Or 3 times 2 gets us 6. Minus 2 is going to get us 4. 3 times 3 is 9. Minus 2 is going to get us 7. 1 times 3 is 3. Minus 2 is 1. Okay? So that gives us the equation there. And then we can ask ourselves, is this a linear pattern? Okay? So basically, is this a line? So let's just grab our ruler, our straight edge, and let's check it out. So is this pattern linear? If I draw that line straight through, it connects all of them. So yes, it is linear, and the reason why is because it has a constant rate of change. And you're going to see that constant rate of change in the graph. So we could say that it's a straight line, it's linear in the graph because the rate of change is 3 every time. We could say the rate of change is 3 every time on our chart as well. Even on our figures up here, we see that rate of change of 3 times the stage. And then that is it for tonight, guys. Thank you for watching.